Okay, we're now recording, and I'll get the PowerPoint set up for where we were or where we left off. But before I do that, before I get into that, I meant to make these announcements earlier, I forgot to. Usually don't put announcements on there. But I did say they did remove everyone from the roll that was not paid, and Jeremy's here, right? Okay. But they're letting people back in. If you are going to complete payment, please don't miss class. Be here. It's just kind of crazy the way we're doing now. Okay. Are any of you getting ready to graduate, like this term or summer term? Okay, you are. Have you already done the graduation notification and application? Not yet. Okay. Please get that done sooner better than later. Okay, the absolute deadline is February 28th, which is a month away, more than a month away. But don't wait till then. Get it done now, so if you do need to pick up another course that you didn't know you needed or something like that, you can still get one second mini term perhaps, okay? Or if it's not being offered, they'll find something and do a course substitution. But there's a lot of stuff to do. The best thing to do is to apply to graduate the term before you're scheduled to graduate. That way you can find out if there's anything missing before you register for that last term, so you can get it all done to begin with. So always try to first apply, notify and then apply to graduate the term before you're scheduled to do so. Okay? Now, they say summer and fall, spring or summer. Okay? If you're graduating in the fall and not coming in the summer, I would go on and do your application for graduation for fall. If you're not coming in summer, do it this term before you register for fall, so you'll make sure you register for the right classes. So you still got some time there because we aren't going to start registering for summer and fall. We do those together because not everybody comes in the summer. We won't do that until after midterm. So you've got plenty of time there, but it's still a good idea to apply early. Don't put it off. And I told y'all earlier, but not everybody was here, I didn't know they had this, okay? But there's 3 of these, and these are all out of date. These were December scholarships that are offered, printed front and back. There's a ton of them, and for pretty significant amounts of money. If I imagine they have Januaries in the Financial Services Office, they may even already have Februaries there, because a lot of them is the first day of the month. So please, if you're interested in applying for a scholarship, go to Financial Services Office, ask them for the listing for January and February deadlines. Okay? Get that done. All right, now let's go over. Okay, if you're in the class, you can access Blackboard. Know how to do that, right? Okay. In Blackboard, when you go to the home page for this class, okay, you'll see in the upper left corner a series of tabs. One of those is home page, one something else. Usually third, fourth, second, third, somewhere in there is one that says content. See, I see the instructor side. I'm not sure the student side is exactly the same order, but if you click on content, then what you'll see there are the course syllabus. You'll see the research paper instructions. You'll see my locator card. I posted there several websites that either students have told me about or I found that I thought might be useful for you, okay? So if you're having trouble understanding the way the book presents or the way I present, you want a second opinion, a third opinion, another viewpoint, then by all means take advantage of those aids. Ryan's here. All right. They're out there. They're free, okay? I think all of them are free, okay? So those are there. There's several of those, 4 maybe, something like that. Then there is, as you scroll down, and one of those is called MathVids. Okay, that's a website. But then you'll see one that says MTH112 YouTube videos. That's where I put the screencast-o-matics. Now, all three of the ones we've done so far, last Tuesday and Thursday and past Tuesday, then today's will be there sometime later today or tomorrow, probably tomorrow. I'll get into that later. But anyway, those are there. Now, I had a decision to make, and you let me know if you don't like it, okay? I decided after the fact to use the same playlist that I did for last term. I taught MTH112 last term using Screencast-O-Matic and YouTube. So what I decided to do was, just as I put a new video in for this term, I'll take off one from the last term. So you can look ahead if you want to. That's the reason I did it. In case you know you're going to miss a class, you can look ahead and see it. You know, or while we're doing it, you can see they don't follow lockstep, but they're pretty close. Okay? So if you don't like that, I can understand it. I can take all the old ones off. It's easy to do. Okay? I have my work study student do it. That's really easy. Okay. He's actually far better at YouTube than I am. But the problem with doing this, and I don't know if there's a way to get around this, they put them down in the order given. So this terms are the last three that are on there. You have to scroll all the way down. I think there's something like 28 videos. So you have to scroll down. You have to watch them all. You just have to scroll down to the bottom and pick up the last one. The first one you want to see is the one that says MTH112 Syllabus. The next one, MTH112 Research. And the next one, MTH112 Section 1.4. Okay? And if you go and watch those videos, you'll hear everything. In that syllabus, I went over the syllabus. It's there in content, static. You can read the syllabus, but it's also down there, and I talk about it. That's in the YouTube video. Same with the research paper. You can read what I say here. You can hear me talk about it down there. Okay? And then we also talked about safety and other issues like that. So that's how you can catch up anything you missed so far. Okay, not as good as being here, but at least it gives you a sampling of what we did. Okay, now I want to know any questions on anything we've done so far. Yeah, homework will be fine. Okay, let me get, oops. It's Michelle, isn't it? Okay. Now, again, since I already said this earlier, let me say, oh, here's another. Okay. Is it Justin? No. Huh? Tyrell. Okay, sorry. Still learning names and faces. And I have a really good memory. It's just short. So after 16 times, if I miss it, then you can start throwing things. And this is Nathan, I think. He was in my class last term. That's the only way I can keep him straight. Well, I can't keep him straight. Never mind. Okay. All right. Was there a homework question? Okay. .43. This is, make sure, page 45? Okay, yeah. All right. Let me get the pen set up. Okay. All right. This is page 45. Section is 1.4 exercise. And number 45, you said, right? Or 43? 43. Okay. Again, good memory, just short. Okay. 43. Says, find the values for which f of x is equal to 0. These exercises find all the real values of x such that f of x is equal to 0. 43 gives us f of x to be x cubed minus x. So what's the first thing we're going to do? The question says, find all the values of x, all real values of x, such that f of x is equal to 0. Second, set it equal to 0. That's how we're going to find it out. That's what it said, where f of x is equal to 0. Okay? Is it Justin? All right. Does anyone else come in that, since I called the roll, that I may have missed? Okay. All right. So, where do we go from here? Now, if this were a linear equation, meaning the maximum exponent would be 1, then you solve for x. Okay? Ultimately, you're going to do that also. But when the maximum exponent is greater than 1, what's our first step? If you could do it, factor, exactly. Okay? And does this factor? How could you factor that? Say again? Okay, no, it's not a difference of cubes. That's a cube, but this isn't necessarily a cube. Okay? Before we go any further, is it Brianna? No. Yolanda, sorry about that. Okay. All right. Whoa, okay, Shay's. All right, people coming, okay. All right. All right. Yeah, this isn't a difference of two perfect cubes because that's a perfect cube, but that's not necessarily a perfect cube. If that had been an 8 or a 1 or a 125 or something like that, yeah, that would have been a perfect cube. Not. Any other ideas? Second? Factor out an x. Excellent. Excellent. Okay. So factor out an x, and what do you have left? X squared minus 1 equals 0. Are we through factoring? Why not? Now we have a difference of two perfect squares. What does that factor? X plus 1 times x minus 1. And that's equal to 0. That's what we're looking for. All the x's that make that function equal to 0. Now that we factored completely, what do we do? Set each factor equals 0 because the only way you can multiply three entities together and get 0 as an answer, one of those entities has to be 0, at least one. So what's the first one? Either x equals 0 or x plus 1 is equal to 0 or x minus 1 is equal to 0. Well, there's a value x which makes that function equal to 0. We got 1. How about the next term? Yes, subtract 1 from both sides, and that gives us x equals negative 1. There's a second one. Or add 1 to both sides, and that gives us x equals 1. There's our third value for x that makes that equal to 0. And here's a little hint. If you have looked for the maximum exponent of a polynomial, and that's the most number of solutions you can have. You may have fewer than that, but you can't have any more. That's a 3. We got 3. Quit looking. That's all of them. Now, what you might want to do is make sure you got the right answer. I always like to do that. What happens if you put a 0 in here? 0 minus is 0. Yes, that works. How about a negative 1? What does this give you? Negative 1 plus 1. That's equal to 0 because minus a minus 1 is plus 1. Okay, how about this one? 1 minus 1 is 0. Yes, all three of those work. We're guaranteed we have the only 3 and the right 3 solutions. Does that answer your question? We found all the values for x that makes that equal 0. Any others? Yes? A little louder. 23C? Is that what you said? Okay. My hearing's bad, folks. Okay. Let's clear all this print. Anyone need it any longer? Okay. Huh? Okay. Okay. All right. So let's do 23. Same page, same well, Actually, it's the previous page, page 44. Same section, number 23, you said? Okay, 23C. Okay. Here, in this it says, in these exercises, evaluate, if possible, the function at each specified value of the independent variable and simplify. Well, here's 23C. 23C, g of t, good old Georgia Tech there, isn't it? Never mind, okay, is equal to 4t squared minus 3t plus 5, right? Yeah. All right. And the C part says, evaluate this. C calls for, they're asking for what is g of t minus g of 2. T for 2 and 2 for t, right? Okay. What do we do with that one? Okay, the first part is exactly this, okay? So this part will be 4t squared minus 3t plus 5 minus, what do we have to do now? Plug in the 2 for the t. So g of 2 is equal to 4 times 2 squared, see it? Help me? Minus 3 times 2 plus 5. Now evaluate it. Okay, what do we do first? Exponent. So that'd be 4 times 4 minus 6 plus 5. This would be 16 minus 6 plus 5. That would be, a little louder, 10 plus 5 is 15. So that would be g of t is the first part minus the second part, which is 15. Okay? Can we simplify that any? Okay. Combine like terms, that would be 4t squared, that doesn't have a like term, minus 3t, that doesn't have a like term, but this does. What would that give us? Negative 10. There we have it. Does that make sense? Answer your question? Any questions on that? Okay. How do you eat a 5,000-pound elephant? One bite at a time. So just take every step, one bit at a time, and combine them together. You'll get your answer. Okay? Good deal. Any others? Glad to see y'all are doing the homework. Excellent. All right. No others? Okay, where I think we left off, at least where my mark was, and you let me know because my slideshow wasn't in the right place and it made me worry. Weren't we doing example 6 and we got the A part done but didn't have time for the B? Is that where you have it? Okay. So, since they don't have this on the slide, I'm going to use this other slide again, just to keep from having to go back and forth between PowerPoints. Here we have, here we're finding all the values for x for which f of x is equal to g of x. That's what the thing is asking. Find x. Okay? Here is the B part, and the B part is f of x is equal to x squared minus 1, and g of x is equal to negative x squared plus x plus 2. Okay. What's your first step? Set them equal to each other. That's what it says. Here's the f of x. Set that equal to g of x. So that would be x squared minus 1 equal to negative x squared plus x plus 2. Now, what's your next step? Say again? Okay, get everything on the same side. how do you determine which side to go to? It really doesn't matter. You can go either way, but how do you do it? Second? Second? You want everything to go from the right side or to the right side? From, I like it too. Here's what I go by. I find the leading term, the term with the largest exponent. There's x squared, there's x squared. I go for the largest value of those. Well, plus 1 is greater than minus 1. I move the little to the big. And then after that, move everything else to follow it. Okay? So here I would add x squared to both sides. Okay, what else? Subtract x from both sides. And also subtract 2 from both sides. Okay, what do we have on the left? 2x squared minus x minus 3 is equal to, ding, ding, ding. Notice the sound effects? 0. Okay. What do we do with that? Why did we do that anyway? So we can factor it exactly. And I factor by what they call, what I call unfolding. I've never seen anyone else call it that. Let's see if we can factor that. If we can't factor it, what would we use? Quadratic formula. Let's see if we can factor. Now, I like to unfoil, okay? What does that mean? Take my first term. What's the only possible factorization for 2x squared? 2x times x. Write them in. It's the opposite of foiling. 2x times x. Except I don't do them in the right order, because then I go to the sign of the last term. And what is it? A negative. What does that tell me about these two signs? They're going to be different. 1 plus and 1 minus. Do you have a preference? Say again? Plus minus? Plus minus. Okay? Now what's the only possible factorization for 3? 1 and 3. Is that how you want it put? Why not? 1 and 3. Now let's check it. Okay? This method is also called trial and error. Here's our trial. Let's see if we made an error. Okay? Now we FOIL. And what does that give us? 2x squared. I like it. Minus 6x plus x is minus 5x. Not the right answer. You've got the wrong number. So change numbers. Okay? So let's go in there and make this the 1 and that the 3. Okay? 3 here, 1 there. Now let's try it again. 2x times x is still 2x squared. Like that. This one gives us negative 2x plus 3x. That gives us plus x. Wrong again, except what's wrong now? The sign is wrong. The number's right, but the sign's wrong. So now we change the sign. Okay? This is my rule. I don't know if other places do it this way, but to me this makes sense. Now let's try it again. 2x times x is still 2x squared. You got plus 2x minus 3x, that's minus x minus 3, you got it. Now what do we do? Set each equal to 0. 2x minus 3 equals 0, or x plus 1 equals 0. Got to be one or the other, or both. And what do you get from the first one? Now we solve for x. Say again? Add 3 to both sides, and that gives us 2x is equal to 3. Divide both sides by 2, and that gives you x equal 3/2. There's a solution, we hope. How about the other one? Subtract 1 from both sides, that gives us x equal minus 1. There's our second solution. What's the maximum exponent? 2. That's all we expect. Let's see if they work. Ugh, okay. What's 3/2 squared? Say again? 9/4 minus 1. Okay, that would be 9/4 minus 1. Well, how many fourths is 1? 4 fourths. So you could write that as 4 fourths, right? 9 fourths minus 4 fourths is 5 fourths. Okay, that's your F. Let's do the G. Well, we already know what this is. That's minus 9 fourths, right? All right. This is Alexis and Allison, right? Okay. Has anyone else come in, snuck in the door while I wasn't looking? Okay, good to have everybody here. Still missing a couple, but good attendance so far. Okay, so we were just checking our answer here. We did the f of x. Now we're doing g of x. We had minus 9 fourths plus 3 halves plus 2, right? Okay. Well, we need least common denominator of 4. So here we're going to have to multiply by 2. So we multiply the numerator by 2. Here this is over 1, so we have to multiply by 4. So we multiply the numerator by 4. So this gives us minus 9 fourths plus 6 fourths plus 8 fourths. 8 and 6 is 14 fourths minus 9 fourths is 5 fourths. Look at that. Okay. 14 minus 9, 5. Yes, F is equal to G. Got the fraction done. That's the hard part. Let's do the whole number. That should be a lot easier. What's negative 1 squared? 1. Minus 1? 0. Well, let's try this. What's minus negative 1 squared? Minus 1 plus or minus 1 is minus 2 plus 2 is 0. Yes, 0 is equal to 0. That works also. Good deal. They got it right in the book. Good for them. Now, I said this earlier, but I'm going to say it again because we've got some new folks here today. Every example, this book, I don't like the publisher. I don't like Cengage. I really don't care for them. I think they overprice the books. But this author is one of the best authors I've ever taught from. Here's one reason. After every example, I don't think he misses any of them. After every example, he gives you what is called a checkpoint. And that's the first thing I would do once class is over and you're not in another class, you have a little free time, go back and try to do all the checkpoints for the problems we did in class. Because if you reinforce this early, that makes it yours. Right now you're spectating. Then you're playing the game, okay? So get in there and play the game. A lot difference, isn't it? We got a baseball player in here, right? You'd rather be on the bench or out there playing? Okay. Bench? Oh, no, I didn't hear that. No. Okay. Now, so go and do the checkpoints. Then do the homework exercise. You can wait and do that when you get home or start that as soon as you can, too. The sooner you do it after class, the better. Okay? Used to be with Integrity, they would be uploaded almost immediately. You can check it. But guess what? What if you can't? You can't figure out, you can't remember how to do this. You have to wait till the next day of class to ask me? No, look at this. After the checkpoint, audio, video solution in English and Spanish at larsonprecalculus.com. He provides support, okay? So every checkpoint, if you can't figure out, can't remember how to do it, try that first. Then later, when I get this on YouTube and that kind of stuff, you can go back and check that too. All right, good deal. I'll do another one of those later. All right, let's move on to domain of a function. Wow, we've talked about this several times, haven't we? Must be important, folks. They keep bringing it up. The domain of a function can be described either explicitly or it can be implied, which would be implicitly, by the expression used to define the function. Now, why don't they show you something about an explicit? That'll come up later. They're going to the implied, implicit domain. is a set of all real numbers. Notice where we start. We assume all real numbers except those that you can't use, okay, for which the expression is defined. So here's one. F of x is equal to 1 over x squared minus 4. Okay? Now, where will we assume this is good? Start off with all real numbers. We assume it's all real numbers unless we find some that we can't use. Now, what operations do you see in this function? Say again? Okay, it's a fraction, which means you're using division. Okay, you're squaring, you're subtracting, and you're dividing. Guess what? I can square any number in the world, no sweat. I can subtract any number in the world, any real number, no sweat. You'll still get a real number. But we sweat a little bit with division. When do we sweat with division? You can never divide by 0. So in other words, that denominator cannot equal 0. Let's take exactly what we just said and say x squared minus 4 cannot equal 0. We said something, we wrote it down in math speak, right? We translated that to math. What do we do now? Say again? Solve. How do you solve that? Say again? Okay. Now she's doing that, and it's okay, but you might, let's try it. Okay, let's try it. Add 4 to both sides, and that tells you that x squared cannot equal 4. And what would you do then? Take a square root of both sides, and what would that tell you? X cannot equal 2, right? Plus or minus 2. You think you'll always remember to do the plus or minus? It has a chance of forgetting to. When I say, what's the square root of 4? What do y'all usually say? 2. Okay. You forget about the minus 2. Now, let me show you, I was in the U.S. Navy. Now, last term in one of my classes, I had a Marine in the class, and he laughed too loud when I told this one. In the Navy, we used to say, you've got to make everything sailor-proof. So not even a sailor will screw it up, you know. And that's hard to do sometimes, okay? The Marine laughed too loud. Okay, but here's how I would make this sailor-proof. If I went back to this, or student-proof? No, I didn't say that. Okay, here's what I think I would do, okay? And you can do it the way you did as long as you remember the plus or minus. But what would you normally do if you have an exponent greater than? You would factor. And how does that factor? X plus 2 times x minus 2. And that cannot equal 0. So what do we do next? So each of them. X plus 2 cannot equal 0. Now here's the only difference. With a non-equal to, it's not an or, it's an and. Not or, but and. You can't have either one of them be 0, because then it would be, okay? X minus 2 cannot equal 0. This gives you negative 2, subtract 2 from both sides. That'd be x cannot equal negative 2, and over here, x cannot equal 2. See, there's no way you can, well, y'all will figure out a way, but this is a lot more likely to keep you from losing that minus 2. There it is, okay? So, in other words, let's go back where we began. All real numbers except you have to exclude x equal negative 2 and x equal positive 2. All other real numbers of the world, that's the domain. So how do we express that? There's actually 2 ways you can do that. The first of these, well, here's what they do. That has an implied domain of all real values x other than x equal plus or minus 2. So that's one way you can write it out, okay? Another way you can express it in set notation. the answer, the domain of this function f, I'm just using that, is equal to set of all real numbers x such that x is not equal to plus or minus 2. Basically, it's the same thing as this. It's just writing it with symbology rather than having to write all the words. Now, this book and many of the current books love using what they call interval notation. To me, set notation says it all, but interval notation, and here's how I suggest that you think of it. Picture a number line, okay? That's all real numbers, right? Okay? Identify where your 0 is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, those are your all real numbers. And everything in between, you know, I just ticked off those. Okay, now what this tells me, you have to exclude x equal negative 2 and exclude x equal 2, right? Every other number on that line, every pixel on that line represents a real number. Those are fine. Just plus 2 and minus 2 are not. So, in interval notation, that would be the domain of f would be, okay, where is it starting over here? The arrow. Say again? Negative infinity, okay? It starts with negative infinity. Now, with either infinity, you always put a parentheses. So it starts at negative infinity, and it goes all the way to negative 2, but does it count negative 2? No, so we put a parentheses. If it counted negative 2, we'd put a bracket, okay? If it didn't, you put a parentheses. Now, we union that with, we're excluding negative 2, and where do we pick up after that? No, you pick up at negative 2 again, but you don't include negative 2. So you open the parentheses again. All you're missing is minus 2, okay? And how far does that go? To plus 2, so everything in here, and do you include plus 2? So you put parentheses, and then you union that with starting at positive 2, but with a parentheses, because you're not counting that, and how far do you go? Infinity, and that always uses a negative parentheses. To me, that's a lot more writing. This says it all just as well, but the book loves that notation. Right here, they just say it in words, okay? But those are two notations you can use, okay? You can write it in words, you can use whatever makes sense to you. Now, are any of you missing the fact that I haven't even mentioned enhanced WebAssign? I don't know if your previous teachers used that. If they did you like it? Did you find it? Okay. I really don't care for it that much now. Maybe far better than back when they first came out or first started getting us to use it. But I spent more time trying to help students figure out how to do WebAssign than I did teaching math. And then I spent more time trying to convince them, no, your answer is right, even though it's told you it was wrong. Okay. Yes. And sometimes you don't know which form of the answer you want. You don't know if they want it in words, they want it in set notation, or want it in interval notation. You may have said it correctly, but it's not in the way they want. It's a dumb computer program. It can't think. It can't say, oh, you have several options here. It's only whoever programmed it, that's the only answer they're looking for. That's why I really don't care for it much, because people get so frustrated. Oh, I got the wrong answer. What did I do wrong? And you spend all sorts of emotional energy and find out you had the right answer anyway. So that, to me, is why make math more frustrating? It's fun. Don't make it frustrating, right? Fun, right? Yes, okay. All right. So that's my little soapbox. If any of you want to use Advanced WebAssign, I can set it up for you, put everything out there, and let you use it to your heart's content. But guess what? This book has all these free aids, study aids. To me, it has all the advantages of Advanced WebAssign, and you don't have to buy it, okay? Or get frustrated with it. Okay, never mind, I didn't say that. Okay. So, All right, I think we beat that to death, didn't we? Let's go back and review. We start with assuming all real numbers unless we find some things you have to exclude. And you mentioned one. Anytime you see a variable in a denominator, you have to check and see if that ever could become zero. The denominator becoming zero, not the variable, the denominator. Okay? If it can, you have to exclude those values. The only other thing we have so far is square roots. What can you never take a square root of? You can take a square root of 0. You cannot take the square root of negative numbers. So that's the other one you have to watch out for. Later we'll get other things, but we haven't covered them yet, like logs. Logs can't be negative, but they can't be 0 either one. So there are other things that you have to exclude. So far, those are the two to watch out for. Variables in denominators and variables inside a square root. Cube roots, no sweat. Fourth root, sweat. Fifth roots, no sweat. Yeah, okay. Any even root, sweat. Okay. Odd roots, no problem. Okay. Next. Another common type, here I go. Another common type of implied domain that is used to avoid even square roots of negative numbers. You just can't do it, okay? Not in the real number system. So if this is your function, f of x equals square root of x, guess what your domain is? What do we assume it is? All real numbers unless you find any it can't be. What can you tell me about that x? What did you just say? It can't be negative. I need to write that mathematically. How do I write that? X is, okay, I could write out the words. I'm too lazy for that. Say again? Okay, now just give me the, no, okay, it could be equal to or greater than 0. Positive numbers are greater than 0. You can't do 0, so you put greater than or equal to 0. That says it all. Okay? Now you can write that in interval notation. In set notation is the domain of this function f would be the set of all real numbers x such that x is greater than or equal to 0. Okay, that says it all. You could write just that or that. Give me the interval notation. Does it help to do the number line? Yay or nay? Okay, you're going to start with the domain of f would be what? No, can you have negative infinity in there? We said x's have to be greater than 0. You can't have negative anything. Start at 0. Do you count 0 or not? Yes, because of the equal sign. So what symbol do we use? Bracket, 0, comma, positive infinity. It goes forever. Positively. That says it all. Set of all real numbers, starting with 0, that the equal sign means you put a bracket there, and it keeps going up, negative infinity, no end. None of those negatives you can include because they're less than. So you see, here's the words, and then they put this. They didn't on the last one, but here it is there. Okay? Do you understand that? Does it make sense? Okay. Okay, in general, the domain of a function excludes values that would cause either division by 0 or that would result in the taking an even root of a negative number. Can't do it. You have to have positives under even radicals. So if this radical has no symbol, if it has no number in this, what do we assume it is? It's a square root. That's a 2 in there. If you don't see it, assume 2. How would we indicate some other root? We put the index. Cube root, no sweat. Fourth root, you have to do this. Same thing. Any even root, if it has nothing, meaning square root, 2, 4, 6, 8, 24, 87, 86, any even root, you have to then do this. Odd root, no problem at all. Okay. So here we have some examples. This is example 7. Okay. Find the domain of each function. You tell me what you think the domain of f would be. Okay? Except that this is a discrete function. It's only defined for 5 values. So its domain is, it's the set of what numbers? -3, -1, 0, 2, and 4. That's your domain of that function. This is an explicit domain. It only is valued for those values. None of the ones in between, only those. The domain is the set of all first values. The range will be the set of all second values. That's your domain. How about G, the B one? The set of all real numbers except -5. So let's express that in set notation. That would be the domain of G would be the set of all real numbers x such that x is not equal to -5. Now let's express that in interval notation. Where do you begin there? In parentheses, -infinity up to -5, parentheses, union, parentheses, -5 to positive infinity, done. There it is. There's the domain of G in interval notation. All right. Now they snuck something in here on you. The volume of a sphere. This is what the formula is. V is equal to 4/3 pi r cubed. What would you say the independent variable is? Pi is a number, just like 4/3. R is the independent variable. What's the dependent variable? V, okay. So we're looking for all the possible values for R. What would you say? All real numbers except this is the volume of a sphere. I want you to draw me a sphere that has a radius of -3. You can't do it. If it's a sphere, a ball, it's got a positive radius. You can't even have a 0 radius. So this is an implied domain that is applied by the nature of the problem. The fact that it's a physical problem, you can't have negative radii. So what would be your answer? Yes, R is what you say? Greater than 0, not greater than or equal to, greater than 0. So you could express that as the set of all real numbers. Real numbers? Yuck! This is such a sorry little program. Okay. All real numbers are such that R is greater than 0. Give it to me in interval notation. Open parentheses, 0, comma, actually infinity. Now, in reality, you can't have an infinite football either, but there's no limit to what that could be, so that's what that's for. So there's your volume of the sphere.
If it has to be greater than 0, would it be a bracket of 1, since it can't be anything less than 1?
You can't, okay, say again now?
Since it can't be equal to 0 or less than 0, would it be a bracket of 1? Since it changes.
Okay, yeah, but you could have a radius of 0.5, couldn't you? Yeah. So anything greater than 0, 0.0001, okay. Awfully small sphere, but you could have it. So yeah, anything greater than 0. Can't include 0. Okay. How about H? Start the nibbling one bite at a time. What can you tell me is true? The thing that's inside that square root cannot be negative. What's inside the square root? 4 minus 3x cannot equal, no, I'm sorry. I said it wrong. Is what? Greater than or equal. You can take the square root of 0. You just can't take. So it's greater than or equal to 0. That's the key. But now we have to solve for x. How do we do that? Subtract 4 from both sides. That's a good start. And that gives us negative 3x is greater than or equal to negative 4. Next, divide both sides by negative 3. And what does that give us? X is... Okay, here's the deal, folks. When you have directional inequalities, if it's a not equal to, no sweat. But if it's a directional inequality, less than, greater than, less than or equal to, greater than equal to, you can add the same thing to both sides, it still stays the same. You can subtract the same thing from both sides, it still stays the same. You can multiply the same thing on both sides of that inequality by a positive number, stays the same, but if you multiply or divide by a negative number, you flip the inequality. You flip the direction. That's the only thing you got to remember for these directional inequalities, multiplying or dividing by negative numbers. Positive numbers, no sweat. Adding or subtracting positive, negative, no sweat. But multiplying and dividing by negative, you have to flip the direction. And what would that be then? Less than or equal to 4/3. So how in the world would we express this? Set notation? Pretty easy. Domain of this H, I can't write, would be set of all values X such that X is less than or equal to 4/3, just like we did. In fact, I don't need all that. That to me says it all. But to get the answers in the back here. But interval notation would be what? Domain of H would be, where do we begin? Negative infinity. What is that preceded by? Parentheses, negative infinity, comma, 4/3, bracket. Got it. All those values less than or equal to 4/3. Okay? Because when you put 4/3 in here, the 3's divide away, you get 4 minus 4 is 0. And then everything else has to be, this has to be less than that, because if you go greater than that, this becomes, you know, if you put in a, say, 8/3, that would be greater, right? The 3's go out, and you have 4 minus 8 is minus 4, you can't take a square root of minus 4. So, yeah, it has to be less than. Got it. Any questions on that? All right, now, I'm going to erase my markings here because they're going to write their answers. I don't know if they'll use, no, they go to a new page, it doesn't matter. That first one was a explicit domain. It told you exactly what ordered pairs were in that function, so therefore you just pick the first values of those ordered pairs. Okay? There's your domain. This is a good thing to look at. Make sure none of those shows up twice. If they do, they better have the same second value, otherwise it's not even a function. Okay? This was. Okay, the B one, excluding the x values that yield 0 in the denominator, would mean set of all real numbers except x equal -5. I like to say all real numbers x such that x is not equal to -5. Says the same thing, okay? They didn't write it in either notation. They just did it. Okay, because that function represents the volume of a sphere, the values of the radius must be positive. So its answer would be r greater than 0. Not greater than or equal to. You can't have a ball with a 0 radius. It's not a ball. It's not there. Okay, nor a negative radius. Okay? And that function is only defined for what's in the radical greater than or equal to 0. If you solve that and they don't show how to solve it, you get x less than or equal to 4/3. Y'all solved it correctly. Okay, makes sense? So the domain would be, and now they put the interval notation, negative infinity up to 4/3, but including it because of the equal sign. So that equal under the directional inequality means you put a bracket. If there's no equal sign there, put a parenthesis. Okay. In example 7c, note that the domain of a function may be implied not by some numerical reason, but for a physical context. Okay? Like if you're talking about the area of a rectangle. Can you have a rectangle with a negative length or width? No! Has to be positive. Okay. Not a 0 width or length either. For example, that equation, v is equal to 4/3 pi r cubed, you would have no reason to restrict. Okay. If they didn't tell you it was the volume of a sphere and say, what's the domain of that, you say all real numbers. But we know that is the volume of the sphere. They told us in the problem. But the physical context implies you can't have a negative or a 0 radius. All right. That was example 7. We now go to applications, and here's example 8. Okay? You've got a job. Congratulations. You work for a marketing department of a soft drink company, and you're experimenting with new can for iced tea that is slightly narrower and taller than the standard can. For your experimental can, and they just threw this out there, the ratio of the height to the radius is 4. Now, when they make a statement like that, translate this English statement into math. What do we mean by ratio? Say again? Okay, you could write it that way. Well, okay. But what does it say? Ratio of what? Height to radius. Now, you're saying h:r is equal to 4. Okay? Now, that is one way you can refer to a ratio. But that is a mathematical operation. What mathematical operation says that? A ratio is comparing two numbers in what sense? The sum, the difference, the product, division sense. Division sense. In fact, think of that as the dividing line. This is h/r. Ratio of height to radius is equal to 4. And you could put 4:1 if you wanted to. Okay? So that was in the problem. That's what you're starting with. You have to have that. Why, I'm not sure, but you have to have it. And you see they wrote it right over there. But I like you to be thinking of translating English to math. Okay? Now, it says, write the volume of the can as a function of the radius r. What is a can anyway? A tin can, a soft drink can. How would you describe it? Cylinder, and it's a special type of cylinder. What's the base? Circle. And does this lean? Is this the Leaning Tower of Pisa iced tea can? No, it stands up straight. So that means it's a right circular cylinder. Okay? That's how you describe it. This can is a right circular cylinder. Does anyone happen to know what the volume of a right circular cylinder is? Let me give you a hint. Huh? You could if you wanted to. That's a legitimate thing. But a volume of anything that's regular. Now, if this was some weird-looking thing, you have to really do a lot of weird things. But if this is a regular shape like we have, right circular cylinder, the volume of that would be the area of the base times the height, right? The area of the base times the height. What's the base of a right circular cylinder? It's a circle. And what's the area of a circle? Okay, that's the circumference of the circle. What is it? Say again, pi r squared. I always thought pi were round, but pi r squared. Never mind. Okay. So it's pi r squared times h. There is the volume of a right circular cylinder, or that tin can. But this is expressing the volume as a function of radius and height. Now, pi is just a number. That's just like if it was 3 there, or 15 or something. Don't worry with that. But we want it only in terms of radius. How can we get the h to be in terms of r? This is true for this can, right? Let's solve h. Solve for h. How would you do that? Multiply both sides of the equation by r. Legal move, right? The r's go out here. H is equal to 4r. So you say v is equal to pi r squared times 4r, right? Now, clean that up a little bit. 4 pi r cubed. Got it. Now you have the volume as a function of radius alone. Yeah, it's got numbers in front of it, but the variable is radius. Okay. Now, write the volume of that can as a function of height alone, with no r's in there. How are you going to do that? Okay, yeah, let's go back here, and we had h is equal to 4r. We now solve for r, divide both sides by 4, and now you have r is equal to h over 4. So your v is equal to pi r squared h, but instead of r, we put in h over 4. That would be pi times, what is r? H over 4 squared times h. Well, let's clean that up a little bit. What would that be? Pi times square the h is h squared, square the 4, and you get 16 times h. Now let's clean that up a little bit. That would be pi over 16, that's the numerical part, times h cubed. So there's volume as a function of h alone. Okay? Do you see how that works?
How are you getting this cube?
Okay. Yeah. You mean right here?
Yeah.
Okay. You got 4 times pi times r squared times r. 4 times pi is 4 pi. R squared times r. This is r to the first power.
Right.
If you don't see an exponent, you assume it's a 1. And when you're multiplying same base, different exponents, keep the base, add the exponents. Or,
So basically you just drop down what you had right
exactly.
Okay.
I just rearranged
Okay.
it. Okay? Here's the other way to look at that. What is r squared? R squared is r times r. So r squared times r, which is what we had here, r squared times r would be r times r times r, which would be r cubed. So that's the other way to look at it. Okay? Easier way, add the exponents. Keep the base, add the exponents. But if you want to convince yourself that's right, do it that way. All right. Any questions? Guess what? They have a checkpoint. Go home and do that checkpoint. Make sure you understand it, and if you can't figure it out, they have the audio-video solution in English and Spanish at larsonprecalculus.com. I feel like an advertisement. Never mind. Okay. All right. That was example 8. Oh, here they have the solution to it. V of r, I don't like this notation. This is not V of r. This is V of r comma h. 2 independent variables, okay? Except they're not totally independent because of that relationship. And that relationship that they left on the other page was that h over r is equal to 4, so that means h is equal to 4r. So instead of h, you put 4r, and then you rearrange it putting the 4 out front, the pi out front, those are the constants, r squared times r is r. So now this is v as a function of r, because the only variable you have is r. Pi is not a variable, it's a number. Okay. The b one, you start with the same volume as you had before, but this time, rather than h is equal to 4r, you do r is equal to h over 4. So instead of r, you put in h over 4. You got pi h over 4 squared times h. Okay? Well, now you got to square everything in the parentheses, so that would be h squared over 16. So your number part is pi over 16, h squared times h is h cubed. Now they wrote it this way, and guess what? If this were enhanced WebAssign, and you put pi over 16 times h cubed, it's probably going to tell you it's wrong. No, that's right. This is right too. I mean, there's several ways you could write the answer. Okay, that's why I don't really care for it's computerized programs. Okay, as you can tell. Okay, never mind. Any questions on that? All right, they jumped to difference quotients. But guess what? There's a couple of more examples here. So let's go back and do example 9. Okay. A batter hits a baseball at a point 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees. Now, I like to draw pictures, okay? I don't draw pictures well, but when I'm trying to figure out a math problem, I found out that pictures are worth thousands of words. If I see it, maybe I can understand it better. But I draw lousy pictures. So here's the batter. There's his bat. Okay? And he's swinging at a baseball. And the baseball is right about here, 3 feet above the ground. Isn't that a sweet spot to swing? And it's about 3 feet above the ground? Oh yeah, he's he's a fielder. He doesn't bat. No. Okay. Yeah, that would be, I'm about 6 feet tall. 3 feet would be right there. Ooh, nice. Okay? If it's over, I can't hit it anyway, but never mind. Okay. 3 feet above the ground. So that's the first thing they told us. Initially, when he hits it, that's 3 feet above the ground. This is 3 feet. Okay? Now, when he hits it, swings that bat and hits the ball, he gives it a velocity, v of the ball here initially, of 100 feet per second. We really don't need all this, but I'm just showing you how I like to draw. Not well. Okay. And at an angle of 45 degrees. Okay? There's his angle of 45 degrees. Now, completely separate, they give it to you. You don't have to figure it out. It says the path of the baseball is given by this function. F of x is equal to negative 0.0032 x squared plus x plus 3. Now, they don't tell you where that came from, and you really don't need to know, but I'm going to give you a hint. Okay? This is measured in yeah. No. Okay. You're dealing with feet, the acceleration due to gravity in feet per second squared. This is a physics thing. 32 feet per second squared. Okay? 9.8 meters per second squared. 32 feet per second squared. Okay? Now, that's sort of where that comes from. Why all the decimals? Because your velocity is 100. And you're squaring it, so you have to square 100, you got 10,000. This is 1/10,000 of that. So don't worry about that. This would be the velocity, but like I said, we're getting that out. But here's your 3. That's the initial position of the baseball, 3 feet above the ground. Okay?
What is the 45 degrees? Is that it?
Okay, it's just part of the problem. Okay? Now, we're almost out of time. We're probably going to have to finish this later, but let me just fill in here. F of x is the height of the baseball. Okay? And x is the horizontal distance. And by the way, if he hit it at home plate, how far does it travel? 0. That's where he hit it. And you put 0 in here, 0 in there, you get 3 feet above the ground. Yeah, this is making sense, sort of. Okay? From there we go on. I don't think we're going to have time to do the problem. It's a little more involved. So we'll pick up at this one next time. Okay? Sorry I'm talking too much. But, oh, here it is. Homework exercises. Starting on page 44. I've assigned some of these before, but some of you knew or weren't here last time. Any of the odds 5 or 7, either of those. Do number 9. There are 4 parts to that. Do any of the odds 11 to 19. Okay? Starting on page 44. Any of the odds 21 to 31. We did one of those in class, 23. Okay? C. Okay? Yes. Okay. Either 33 or 35. Any of the odds 37 to 43. We did 43 in class today. Either 45 or 47. Any of the odds 49 to 55. And then try 61, or let me say any of the odds. Well, let's see. I'd say 61 or 63. Stop there because we're going to do Path of Baseball next, so we haven't done that yet. So we'll stop there. All right, good deal. Have a good weekend. Working math problems is going to make it good, right? Yes. Make it wonderful. Yes. I'm sorry. Okay. Okay. And that's setting, it says what values make that equal that. Okay, so your x squared is equal to x plus 2. Okay. You subtracted. Yeah, you subtracted that from both sides. Okay. Now what you do here is when you have a exponent of 2 or greater, try factoring. If it was just 1, then you try to solve for that. So you try to factor that.
Oh, so
that's the next step.
So,
yeah. Factor next, and then, because you have it equal 0, that's a perfect thing to factor. Yeah. Okay. I'm sorry? Oh, no problem.
I went to the business office and they told me that I was urged at the system.
That's, yeah.
Yeah, but she told me to come in Monday and tell me to
Okay.
and just let you know. But she told me to keep coming to class.
Yeah, keep coming to class. And I would say, anything that is first of the class you can pick up by watching it on YouTube, but since you're purged, you probably can't get to it because they took you out of Blackboard too. Yeah, take care of that. Now, are y'all sisters?
Yeah, we sisters.
Are you twins?
No.
No, not twins, just sisters.
11 months apart. 11 months apart.
Oh, wow. Okay.
Okay, I just wanted to let you know.
Okay, thanks.